Okay, so at a glance, it's not clear what we're given in this question has to do with what we're asked, right? So we're given the unit directional derivative in these two different directions, and then what we're being asked is the direction of fastest increase. Wow, it's just not clear, right? So what I'm going to do is I'm going to start writing stuff down and make connections any way that I can think of, and hope that something comes up, and something nice is going to come up. So I'm going to start with these two givens. The unit directional derivative in the x direction is 4. Let's write that down. Okay, so I'm going to write this down in math language. In the x direction means in the E1 direction. Is this function called f? Yeah, f from R2 to R1. Okay. And I'm given that the unit directional derivative in the second direction is 8. All right, so what can I do with this? Well, here's the thing. That's not just a unit directional derivative, that's a unit directional derivative in the direction of a standard basis vector. So that's a partial derivative. So I can rewrite this, in fact, as partial of f with respect to x. Is that cool? Is everybody happy with that? Okay. And then likewise, this, again, the vector is a standard basis vector in the direction of the second input vector, so the partial of f with respect to y is what that is. Okay. So the problem wasn't phrased as here's the partial derivatives, but in fact that's what we were kind of given, just interpreting appropriately. Okay.
So just before 8.
Yeah, that's
okay.
yeah.
That I like put that down, but like I just like.
Well, yeah. I mean, so now by the way, the question then. Okay, what the question at? What is the direction of fastest increase? So the direction of fastest increase, just to be let me write this down. Direction of fastest increase. It's the unit vector direction indicated by the gradient. So it's this, right? And then you're right to notice that, well, that's the gradient vector. So what it really is it's 4, 8. Whoops. 4, 8 divided by the magnitude of that vector, which is this. Let's see here. Hang on a second. It's, oh, yeah. Let's see. 60, 80. Is it 4 square root of 5? Yeah, that sounds right. I'll take your word for it. There we go. Oh, conveniently, then that common factor of 4, so that's 1, 2 divided by the square root of 5. Yeah. Yep. Everybody good? By the way, here's a neat trick that you can play sometimes. If what you're looking for is, and you see that it is, a unit vector, specifically a unit vector defined, pointing in the direction of that vector, feel free to take this vector and scale it however you want with a positive scalar. It doesn't change the direction that it's pointing. Right? So the unit vector pointing in that direction is exactly the same as the unit vector pointing in that direction. It's the same direction. So another thing you could do is just say, instead of trying to do that arithmetic, you could say, well, 4, 8 points in the same direction as 1, 2. I'll divide 1, 2 by its magnitude. And that's much easier arithmetic, thus giving us the same answer.
And then would the unit directional derivative in that direction be 4 root 5, or would it be
4 root 5? Yeah, absolutely. Because yeah, that's right. Yeah, right. Yep. Everybody happy?
Yeah.